Hello everybody, today I'm going to be talking to you about the questions that were missed the most in exam number 2. By the way, the number of the question in the exam is found on the top right corner of the slide. To begin with, we have this question that says, the dissolution of carbon dioxide in water described by the following equilibrium equation is an exothermic process. To increase the dissolution of carbon dioxide in water, we need to do what to the temperature and what to the partial pressure of CO2. Okay, so first of all, when it says to increase the dissolution of carbon dioxide, what that means is that we want a shift in the equilibrium toward the right, because that's what it was told to us that the dissolution was. The dissolution is this process. So basically, again, we want a shift to the right in the equilibrium. So in order to do that, let's go ahead and start considering the temperature effect. And since in this case we are told that this is an exothermic process, then what that means is that we can treat heat as if it was a product of our reaction, right? We then think about what does that heat need to do in order for the shift to go to the right. Well, to go to the right, that means that we need to actually remove heat or decrease the temperature of the reaction in order to cause a shift to the right. Now, the second part is in regard to the partial pressure of CO2. Remember that partial pressure, whenever we talk about partial pressure, really what we're talking about is the concentration of that gas. So the question here is, what has to happen to the concentration of CO2 in order to cause a shift to the right? And what needs to happen is basically that we need to increase or add more CO2, increase the concentration of CO2 in order to cause a shift to the right. So overall, what we're saying here is that we need to decrease the temperature, remove heat basically, and we need to increase the concentration or increase the partial pressure of CO2. So the answer to this particular question was to decrease and then increase. And the answer choices are different for each of the versions. In this case, I copied the answer choices for version 11. The next question is the reaction of A2 plus B2 going to 2AB has an equilibrium constant Kc of 1.5. This part is important. The following diagrams represent reaction mixtures containing A2 molecules, which are red, B2 molecules, which are blue, and AB molecules, which are red and blue. Which of the three diagrams represents the equilibrium for this reaction? And notice that I put a note on your exam that says, assume that all systems are at the same temperature, meaning that the Kc is going to be equal for all. Also note that these are not supposed to be chronological time shots, but rather are supposed to show the ratio of the products to the reactants at equilibrium. So what you needed to do was to look at the number of molecules of the A2 type or the B2 type or the AB type and figure out what was the Kc for each of the three scenarios, A, B, or C. So to begin with, we're going to write Kc as the products over the reactants. The product in this reaction is your AB, and since the coefficient is A2, we're going to go ahead and square that concentration. Now the reactants include A2 to the power of 1 and B2 to the power of 1. So now we're going to find the value of Kc for scenario A, scenario B, and scenario C. To begin with, the Kc for A is going to be, let's see, what's the number of AB molecules? So that would be 1, 2, 3, 4, 5, and 6. Sorry, I'm not very good with this mouse. So this is a 6, and that 6 gets squared. Now we're going to divide it by the number of A2 molecules. In this case, we have 1 and 1. Therefore, we have a value of 36 here. Now, the Kc for B is, in this case, the number of AB molecules, which is 1, 2, 3, I think that's it, 3, and that's squared, divided by the number of molecules A2, which are the red ones. That's 1, 2, and 3 to the power of 1, and then the number of blue molecules, which is just 2 that are left. And that actually gives us 9 divided by 6, which in fact is equal to 1.5. And finally, we have the Kc for part C, where we have the number of AB molecules being just 2, and that's 2 squared divided by the number of A2 molecules, which is 3, and the number of B2 molecules, which is 3. So what we end up with in this case is 4/9, which is something like 0.44. So obviously in this case, only the Kc for B equals 1.5, which is the value of the ratio of products to reactants that we expected for this particular equilibrium. So the answer to this problem was B, and that is the same answer choice in both versions of the exam. The next two questions that were missed the most were actually bonus questions, so that is okay. That's not a problem because you will be tested on this later on. But the first one is, what is the conjugate base of hydroxide ion? So if we are looking for the conjugate base, that means that this guy is acting like an acid. Acting like acid. Okay, so what that means is that it is going to be donating a proton. It is going to be losing a proton. And remember that a proton is nothing other than an H+, right? We're going to be losing a proton from hydroxide, from the OH-. That means that the OH- is going to be forming H+, plus whatever is left after we have removed the H+. Obviously, that's going to be an oxygen with no hydrogens anymore. And if we think about the charge, initially we had a charge of -1, and if we lost a positive charge, that means that it's going to become more negative. So in this particular case, it goes from a -1 charge to a -2 charge, which is why the answer was actually the O2-. And again, this one might be a different answer choice order for version 2.2. The last question that was missed a lot is the one that's talking about, which is also a bonus question, is the one that asks for which of these is the strongest base. And this one was a difficult problem. What I was hoping is that you were going to be thinking about the fact that the strongest base comes actually from the weakest acid. Let me write that down, from weakest acid. So we needed to think about, what acids do these things come from, and what does that tell us about the basicity of this ion or compound. So to begin with, I'm kind of going to organize my thoughts in this way. I'm going to say, okay, this is the acid that it comes from, this is the base, which of these is going to be the strongest? So I'm going to start with the ClO4-, and I'm actually going to put it up here because I know that this guy comes from HClO4, which is perchloric acid. And we all know that perchloric acid is a strong acid. Therefore, that means that this is going to be a very, very weak base. So I'm going to go ahead and put this. This is my weakest. This is my strongest for the acid. So strongest acid on the top, weakest base on the top. From there, we're going to think about, okay, what else do we know from this stuff right here? Well, I know that NO2- comes from an acid. NO2-, let's put it here. NO2- or nitride ion, it comes from nitrous acid, HNO2. HNO2 is not on the list of strong acids. We know it as a weak acid, right? So it's weaker than perchloric acid for sure. And so this is a good order. That means that this is actually a stronger base than the perchlorate ion. From there, now I have to think about water, and this is actually H3O+, sorry, the hydronium ion. I apologize for that. So, all right, let's think about how this is working out. Obviously, if we think about water or H3O+, water, remember that it wants to stay as water. However, we also talked about the fact that the hydronium ion was actually a stronger acid than our weak acids, because the water really doesn't want to be in that hydronium ion state. It wants to be in its neutral form. So it wants to donate that proton. So it is actually a stronger acid than it is the nitrous acid. So therefore, it's definitely not the strongest base. And if we remember, when we talked about the order of the strength of the acids, we then said that at the very bottom, below all of the weak acids, we had water in its neutral form. That water, again, is not a very strong acid. It's actually a very weak acid because it doesn't want to donate any more protons and become charged. Therefore, this is the order for the acid. So notice that both the hydronium ion and the water molecule fall within the acid behavior as opposed to the base behavior. Now, if we come here, obviously the hydronium ion has a conjugate base, which is water, but that water follows right under the perchlorate ion, meaning that it is a fairly weak base in that, again, it doesn't want to accept any more protons to become the hydronium ion. So it's a very weak base, weaker than the nitrous ion for sure. And then the conjugate of water is the hydroxide ion. That one, on the other hand, is going to be the strongest of this list in terms of the base behavior. Well, here we have the weakest acid. So what I was hoping is that you would go through this whole process and kind of put this table on your own head, knowing the behavior of the hydronium ion and the behavior of water. And from there, you would identify that neither water nor the hydronium ion really want to act as a base. So they're very weak bases. And instead, in this particular case, the answer was that the nitrous ion, out of the choice of the four, is going to be your strongest base. The last thing that I wanted to point out was the exam statistics. So actually you guys did pretty well. The average in the exam was a 72.5, which is very high for chemistry classes. So I want to congratulate you. I hope that you guys continue to be engaged and continue succeeding in the class. This is a distribution. Of course, it worked out for quite a few of you. You guys did very well, but I still have a lot of people that are not doing very well, and I don't want you to be discouraged. We still have half of the semester to go. Remember that the final exam can replace one of your previous exam grades, and so hopefully you'll be able to overcome the problems and be able to succeed in the class. I'd be happy to help you as much as I can. Contact me by email if you want to chat. I'd be happy to meet with you guys individually or in groups using Zoom. Have a great day and talk to you guys later. Bye.